If someone asked me how I would migrate 100 applications, I would not start by moving one application by hand, because a portfolio that large is not a sequence of isolated tasks. It is a delivery system problem. 100 apps means 100 release histories, 100 dependency patterns, 100 secret flows, 100 deployment habits, and 100 different levels of business risk. Some apps may still move through Jenkins jobs or UrbanCode processes. Some may deploy every day while others change once a quarter. And some are simple stateless services while others hold customer state or drive critical business flows. If every team migrates in its own custom way, the program becomes slow, expensive, and dangerous. So the right answer is not a heroic migration, but a migration factory. In this video, I will explain that factory in plain language, from inventory and wave planning to reusable Backstage and harness templates, secure delivery paths, and controlled cutover. First, we will define the real problem behind a 100 app migration, so the solution does not sound like vague platform jargon. Then we will look at the top-level factory model, which moves from intake and discovery to standardization, migration, verification, and feedback. After that, we will cover the inventory work, including the applications themselves, Jenkins jobs, UrbanCode processes, dependencies, secrets, deployment frequency, and risk level. Then we will group the apps into migration waves and explain why simple, stateless apps should teach the program first, medium complexity apps should follow, and high-risk or stateful apps should move last. Finally, we will explain how Backstage templates and harness pipeline templates create a secure golden path, and we will close with the execution loop that makes the whole program repeatable. The first mistake many teams make is thinking migration mainly means changing runtime, as if you move the code, update the pipeline, point at a new platform, and the hard part is over. Large migrations usually fail because the delivery system was never understood, which is why a migration factory starts with discovery rather than deployment. Before you move anything, you need a real inventory that answers practical questions about ownership, build paths, active Jenkins jobs, UrbanCode release processes, environments, dependencies, secret sources, deployment frequency, and blast radius. You are building a map of the estate, not just a list of repositories, and that map tells you which applications are easy to standardize, which ones need extra engineering work, and which ones should not be touched early in the program. Without that map, wave planning becomes guesswork, and once a migration program starts running on guesswork, deadlines get louder while confidence gets weaker. Now let us look at the top-level migration factory as one repeatable system with a clear flow from intake to feedback. First comes intake and discovery, where an application enters the program with its owner, repository, build path, current deployment method, dependencies, data sensitivity, secret model, and release risk. Next comes classification and standardization, where the team scores complexity, identifies missing documentation, decides whether the app is stateless, stateful, scheduled, or tightly coupled, and then defines the target service shape, environment model, secrets path, and delivery controls. Then comes migration, execution, and verification, where the app is onboarded to the new path, tested in lower environments, prepared for production cutover, checked for observability and rollback, and reviewed for hidden manual steps. Then comes feedback, because every migrated app should improve the factory. And when 5 teams hit the same gap, the answer should be a better template, a better checklist, or a stronger platform control, rather than 5 custom fixes. Now let us break down the wave model, because not all applications should move at the same time, and not all applications should teach you the same lessons. Wave 1 should usually contain simple stateless apps because they often have fewer environment surprises, simpler rollback, and lower production risk, which makes them the best way to prove the factory works. Wave 2 can take medium complexity apps that bring more dependencies, more traffic, more environment variation, or stricter delivery requirements, and by then the templates should already be better because Wave 1 exposed the obvious gaps. Wave 3 should take the high-risk and stateful applications last, not because they matter less, but because they need the strongest confidence around data persistence, cutover, rollback windows, external integrations, and approval controls. A good wave plan considers more than technical difficulty, because deployment frequency, business criticality, operational maturity, support readiness, and team engagement all shape how safely an app can move. This is where reusable templates become powerful, because if 100 applications each need a custom migration design, the factory is already broken. Backstage templates can define the intake and service shape by guiding teams through the same onboarding questions and creating the same standard metadata, ownership model, environment definitions, and platform expectations. That means the app does not arrive as an unstructured snowflake. It arrives through a repeatable front door with the information the platform needs. Then, harness pipeline templates can define the delivery path from build and test to security scan, artifact publish, environment deploy, approval where needed, verification, rollback path, and audit evidence. The point is not that every application becomes identical. The point is that every application follows the same secure pattern unless there is a clear reason to vary it. And that is what top-level delivery should look like. Now imagine the execution loop in practice, where you do not start with all 100 apps, but with a pilot set of maybe 5 or 10. Enough to test the factory without spreading hidden mistakes everywhere at once. For each app, the loop should feel consistent. Collect the facts, classify the risk, select the right migration wave, instantiate the Backstage template, attach the harness pipeline template, connect secrets to the approved store, and validate lower environment deployment. Before production cutover, the team should prove observability, prove rollback, understand dependency impact, and schedule the change with controls that match the real level of risk. This is also where governance belongs, because secrets should not be copied casually, approvals should match risk, production changes should be traceable, and rollback should be real rather than something that only exists in a document. The migration factory should make the safe path the normal path, and that is what separates a serious engineering program from a mass relabeling exercise. Here is the simple summary. If I had to migrate 100 applications, I would build a migration factory rather than run 100 custom projects. I would start with a real inventory of applications, Jenkins jobs, UrbanCode processes, dependencies, secrets, deployment frequency, and risk level, because discovery has to happen before migration. Then I would group applications into waves, move simple stateless apps first, take medium complexity apps next, and leave high-risk or stateful applications until the factory has earned enough trust to carry them. Then I would create reusable Backstage templates and harness pipeline templates, so every app follows the same secure golden path, and I would run the whole program as a feedback system that pilots, improves, expands, verifies, and only then tackles the hardest work. That is the real idea behind large-scale migration, one repeatable system for safer delivery. And if this helps, subscribe for more practical cloud, platform engineering, Kubernetes, Terraform, AI engineering, and software delivery videos from Trust Screen.